This lecture was created by Danny Kessler, Associate Professor at Dongseo University and Korea's first PhD in wellness tourism. Look around any university library in Gunsan at 2 in the morning. You will see exhausted students fueled by caffeine slouching over laptops. The physical toll of that high-stress environment is written directly across the face, in dark circles, sagging skin, and early wrinkling. The standard reaction to this physical fatigue is to head to a clinic. People try to freeze the surface muscles with Botox or fill the anatomical gaps with cosmetic injections. Treating wrinkles this way is treating a surface symptom. We have to ask a more precise biological question. Why did the facial structure degrade in the first place? If you only mask the symptom, you guarantee that the underlying biological decay will continue unchecked. The root cause remains entirely unsolved. The human face is not a static canvas. It operates as a highly dynamic biological machine.
To understand how it operates, we must look past the skin and examine the underlying structural architecture of the maxilla and mandible. The prevalent assumption is that an adult's facial bone structure is entirely dictated by genetics. Most people believe that once you reach adulthood, your jawline is permanently locked in place. However, research indicates that adult bone and muscle architecture continually adapt to daily habits. Even fully developed skulls retain the capacity to physically remodel themselves. Redefining the face as a mechanically responsive system shifts the control. Your skeletal structure is a direct output of your daily behavior. Every time you breathe, adjust your posture, or contract a muscle, you apply measurable physical force to your facial skeleton. During rest, directional forces act on the midface. The tongue pushes upward while gravity pulls downward. Biological systems respond to these forces. Over time, the skeleton slowly adapts to the pressure. This permanent remodeling stands in stark contrast to temporary cosmetic fillers. The critical component in this architecture is the maxilla. It acts as the central keystone supporting the entire midface. The exact position of the maxilla dictates both the prominence of your cheekbones and the structural width of your respiratory airway. Therefore, skeletal structure is a physical, chronological record of an individual's long-term muscular habits. We can observe this mechanical adaptation clearly in the typical Korean student lifestyle: highly productive, highly sedentary, and frequently physically compromised. The most crucial mechanical input happens entirely out of sight. Humans swallow roughly 600 times a day. A biologically optimal swallow requires a specific sequence of muscle engagement, anchoring the jaw and pressing against the roof of the mouth. The tongue must press firmly upward against the palate, generating constant structural support. If you maintain an open mouth posture, the tongue drops and that upward pressure is lost. Without palatal support, the facial structure slowly collapses inward over thousands of swallow cycles. Multiplying that single loss of upward pressure by a 600 times daily feedback loop turns a minor postural habit into the primary architect of facial degeneration. Internal muscle posture is only half of the equation. We must also examine external environmentals, specifically modern dietary habits. A late-night study routine usually involves ultra-soft, highly processed convenience foods that require almost zero effort to consume. There is a direct biological relationship between heavy mastication force, or chewing, and the maintenance of dense jawbone structure. When you remove high-resistance chewing from your routine, the bone matrix physically thins and loses its intricate connections due to the lack of mechanical stress. Consuming a low-resistance diet causes the jaw's masseter muscles to gradually weaken and atrophy. Statistical data shows that masseter weakness significantly increases the likelihood of the jaw dropping open at rest, forcing you back into the negative mouth-breathing loop. Relying on a soft diet systematically disarms the face's natural muscular scaffolding, accelerating the structural collapse of the airway and jawline. When we compare modern populations living on soft diets to historical populations consuming high-resistance diets, we see a stark contrast between narrow modern jawlines and robust historical facial structures. This divergence occurred rapidly over recent generations. The driving variable is an environmental and dietary shift, not a slow genetic mutation. This chart shows average airway volume over 5 years. Habitual nasal breathers maintain high volume, while mouth breathers suffer a measurable decline. This narrowed airway creates a biological trap. As the passage shrinks, the individual is forced to mouth breathe out of sheer necessity. The overarching rule of structural wellness is this: genetics provide the initial blueprint, but mechanical inputs dictate the final constructed reality. Your current facial structure is not an unchangeable fate. It is simply the lagging indicator of your historical lifestyle habits. To optimize this biological system, we apply a 3-step framework known as behavioral architecture. First, consciously default to nasal breathing. This properly filters the air and forces the jaw into a closed, secure position. Second, cultivate an active, upward resting tongue posture. This provides the constant palatal support the maxilla requires. Third, reintroduce mechanical resistance into your daily diet. Tougher foods rebuild masseter density and bone strength. Together, these interventions create an integrated feedback loop. Fix the inputs, and the structure naturally follows. Cosmetics alter your appearance temporarily. Conscious habits dictate the permanence of your bone structure. Applying this systems-level logic, fixing root inputs rather than treating surface symptoms, allows you to engineer your own biology. It drives both your long-term physical wellness and your high-level professional performance.